Welcome to lesson 5.5, solving real-life slope questions. So when are we going to use this in the real world? We'll find out. Our objective for today, I can solve real-life questions with slope. All right, flip the page for me. So let's take a look at this first example. It says the table below shows the cost of a different number of goldfish at a pet store. The cost is a linear function of the number of goldfish. Which statement describes the rate of change of the function? So remember, rate of change is the slope. So to figure this out, we have to think to ourselves, okay, that's our m in our equation, right? That's our change in y over our change in x. So from $1.50 to $3, I'm adding $1.50, so it's going up $1.50. And from 5 to 10, we're going up 5. So to find our slope, remember, it's the change in y, which in this case is at 150, over our change in x, which is 5. So 150 divided by 5 is our slope. And when we do that, we get that it is 30 cents for one goldfish. So remember, y is your cost here, right? So y is going to be, it's going to cost 30 cents per, and our x value, our change in x, is for goldfish. So for one goldfish, it's going to cost 30 cents. So let's look at this to see which is our answer. First one, the cost increases 30 cents each time one goldfish is added. 30 cents per one goldfish, that seems like it's our right answer, right? All right, let's take a look at 7. D7. A campground rents canoes for a flat fee of $25 plus $5 per hour. Write a linear function to model the relationship between the number of hours renting a canoe and the total cost of renting one. Let x represent the number of hours and y represent the total cost. All right, so y is our total cost. So we know that y, our total cost, has to equal, then we have a flat fee of $20. So if that flat fee means I only pay that fee once, right? So we have $25 plus $5 per hour. And if we look here, it said that we had to let x represent the number of hours. So we don't know how many hours this is, but we know that it's $5 per hour, which means that our variable x has to go after our 5. So you should have y equals 25, plus 5x. So it says explain the meaning of slope in the context of this problem. So our slope, remember, is our m. It's the number in front of our x, which is 5. So what this means is that to rent a canoe, it's $5 for every hour. So it costs $5 to rent a canoe for each hour. So each additional hour that they rent it, we know the cost is going to go up $5 more, right? All right, flip the page for me, please. Let's take a look at 65. So 65 says below is information on how Jessica and Shelly determine the total amount they charge for babysitting. So here we have Jessica's babysitting rate is pictured in a graph, and we have that Shelly's is pictured in an equation. So here it says, which babysitter charges the lower rate? Well, the lower rate is going to be the lower rate of change. So when we look here, we have to figure out which one has a lower rate of change. So Jessica, well, from a graph, remember, the rate of change is the same thing as the slope. So we want to figure out how much she pays per hour. So if I look here, I'm going to mark my 2 points. I have this point here, and I have my origin. So to get that slope, I have to go up 8 and to the right 1. So my slope, which is y over x, is $8 she charges per our change in y. How much time? For 1 hour. Right, we rose up 8 and we went over 1. So $8 per hour is how much Jessica charges. Now, Shelly uses this equation where t is the time in hours and c is the total cost. So here, her rate of change, or her slope, is the number in front of the t. So she charges $7.50 for 1 hour. I know there's a glare on this, guys. I'm sorry. There we go. Oh, it's so much better, Miss Wall. So I have $8 per hour for Jessica and $7.50 an hour for Shelly. Which babysitter charges the lower rate? Well, that's going to be the $7.50 per hour, which is Shelly. So in my answer, I'm going to write Shelly because $7.50 per 1 hour is, I'm going to say 50 cents less than Jessica's rate. Okay, so here I'll brighten that up for you. So Shelly, because she charges $7.50 an hour, which is 50 cents less than Jessica's, because Jessica charges $8 an hour. Okay, flip the page for me. Let's take a look at this next one. So we have Jeffrey and Fumi walk at different speeds. Fumi's walking speed can be represented by the equation y equals 85x, where x is the time in minutes and y is the distance in meters. The difference Jeffrey walked over the same time is shown in this graph below. Which statement is true? So looking at our choices here, we see that it's comparing the rate of change for Jeffrey and Fumi. So we're going to have to figure out what the rate of change is for both of them. So if we look first at Fumi, I'm going to write this over here, Fumi, right? We see that it's y equals 85x. So x is the amount of minutes. So for how many amount of minutes I have, I'm multiplying it by 85 to figure out how much our distance is. So that must mean that he walks 85 meters per minute. Okay, now let's take a look at Jeffrey and how fast Jeffrey walks. So we're going to put Jeffrey. So Jeffrey walks, so if I have my point here, and I'm going to use the origin as my other point, I have to go up 400 and then to the right 5 to find my slope, right? So I'm going up 400 and to the right 5. So Jeffrey walks 400 meters in 5 minutes. But all of these answers say that we're looking for per minute. So I need to make sure that this is a unit rate, right? I need to make sure that it's per minute, not per 5 minutes. So if I walk 400 meters in 5 minutes to figure out how much he walks per minute, we're going to have to divide these two. So 400 divided by 5 is 80 meters per minute. So Jeffrey walks 80 meters per minute. Fumi walks 85 meters per minute. So looking at this, it looks like Fumi walks faster by 5 meters. So let's see which one is our answer. It says Jeffrey walks 5 meters per minute faster than Fumi. Well, Jeffrey only walks 80. Fumi walks 85. So Jeffrey doesn't walk more. So that can't be it. Jeffrey walks 10 meters more. 10 meters faster than Fumi. Well, 80 and 85. No, that's not true, right? They're not even 10 apart. Then if we look at our next one, Jeffrey walks 5 meters per minute slower. Well, he walks 80, and that is 5 slower than Fumi. So I'm going to say that that's our correct answer. Okay. All right, taking a look at the next problem, I want you to try to do this one on your own. Think about the question. There are 2 parts. There's Katie, who burns her calories with this graph, and there's Rich, who burns it in this sentence right here. So I want you to compare them and try your best. When you're done, please raise your hand to get it checked. All right, welcome back. Let's take a look at the next one. So this one, I would like you to please answer the question. So look at the bamboo growth and how high does it grow in inches depending on the weeks. Okay, so I want you to find that rate of change there for me. And when you're done, please raise your hand to get it checked. All right, welcome back again. We have one problem down here that I wanted to take a look at together with you. So this graph models the cost of holding a banquet at a tea room restaurant. What is the initial fee and cost per hour to hold the banquet at the tea room? So if we look here at this graph, notice that there's this little like zigzag cutoff here on the y-axis. What that's saying is that instead of having to write out 0, 30, 60, and going up by 30 each time like it is, instead of having to be blank all the way and then shoot up, this is kind of telling us we're not going to have the pattern start until right here. Okay, so looking here, we see that it crosses the y-axis at 150. So in terms of the initial fee, how much do they pay right up front? Well, that's going to be our initial value, or our y-intercept. So we know that our initial fee is going to be $150. So knowing that the initial fee is $150, we can immediately figure out our answer, right? But to find the slope, the cost per hour, remember we have to mark our 2 points. Do rise over run, so it goes up 30 over 1. So that means it's going to cost $30 per hour. So just to make sure, I have $30 per hour, and I have 150 flat fee, which is my initial value, my y-intercept. So A is our answer. Okay, please flip the page for me. All right, this next one, students organized the 12-hour dance-a-thon as a fundraiser for their summer camp. The graph below represents the amount of money they raised during the first 8 hours. What was the amount of money raised per hour during the first 8 hours? Show your work and explain your answer. So when it says per hour, right, that means we're looking for our unit rate, or we're looking for our slope, rather. So I want you to take a moment. It looks like this is a good point to use, and the origin, to find out your change in y over your change in x, to figure out what the unit rate is. How much did they pay per hour? Or raise, sorry. All right, so do this one. Please raise your hand to get it checked when you're done. All right, welcome back. I want you to take a look at number 53. Try number 53 on your own. It says, Ingrid types faster than 50 words per minute. Which graph represents the number of words that she can type over time? Okay, so you're going to have to figure out which one of these has a unit rate that's faster than 50 words per minute. Okay, go ahead and do that. Please raise your hand to get it checked when you're done. And that's the end. I hope you had fun. Bye.